Greetings, Statesman. This is lesson 5.3 regarding the congruence of triangles. In particular, we're using the side angle side or SAS theorem. Your textbook provides it as a theorem, but I've seen it widely actually discussed as a postulate. So we're going to actually do a bit of a construction here and use a compass here. It'll be difficult for you to see what's going on here, but I just want you to be able to see that if we have let's just take a triangle here, okay? And we're gonna call this triangle, triangle ABC. And so far, when we've proved triangles or discussed triangles be congruent, we've said that there's three sides and all three angles in two different triangles would have to be congruent. In other words, 6 sets of congruent statements, right? 3 angles, 3 sides. We're going to be able to prove just as much with less information. Just think about the following. If we had 3 sets of sides and only 2 sets of angles, right? That's only 5 things, but that would also prove our triangles to be congruent. Because consider this. If we have 2 of the angles and congruent in 2 sets of triangles, we know through the third angle theorem, the third angle has to be congruent. So we only have to prove 2, right? And the third one automatically becomes congruent. So what we're going to do here is see if we can actually prove just as much with less information. So we're going to start here with point D, okay? With point D, and we're going to construct this triangle, and what this guy's going to ultimately be is show that we're going to have triangle ABC congruent to this other triangle DEF. When we do that, what we're going to do is first construct an angle, copy a segment construction, right? So we're going to spread our compass to the width of A and B, okay? And we're going to get, again, right here with my compass, bringing down my needle from point A and putting it onto point D. And right there is where we're going to go ahead and get our new segment here, which we're going to call DE, which is going to be congruent to BAB. It has to be, right? It's the same exact compass length. So here we go, AB congruent to DE. Now we're going to be able to we're going to go and do the copy an angle construction, right? And we're going to copy angle A. Because if I just copied all 3 sides, I wouldn't be totally sure exactly how much to open up, for example, angle A. So right here, with the compass, what we're going to have is point on angle A, okay, and we're going to make an arc, and that turned out terrible. Let me see here if I can adjust a little bit and get my my stylus to work a little bit more sufficiently here. There we go. Okay, so rotating on A. Okay, and again, I'm going to rotate this guy, and it works better, I'm sure, with your paper and pencil and your actual compass that's going to be able to stick to the paper, right? It's hard to get this this point of this compass to stick to the screen of my tablet. So I've got this arc. I now need to copy this width, right? So go back to angle A, and I'm going to copy the width of the arc, which is at either point of the intersection of the arc with the side. And then once I have that, I'm going to put the needle onto the intersection of the arc with DE, right? And then I'm going to get right there. Good, there we go. I'm going to get that other point through the arc, okay? So the last thing that we're going to do is we're going to construct AC here, right? So AC, I'm going to spread the width, and there we go. We're going to have point C, but I'm going to make sure I have my arc, right? So that when I get point F, I know where to connect it to as long as I go through that intersection. So I know where to effectively stop, right? Over here at this arc. Going back here, F and E, we're going to connect these two. And what it's going to show here is that we have these 2 things congruent, right? Again, D is going to be congruent to A, and then of course AC is congruent to DF. So notice that it's not all, you're right, just through the constructions. Those were the 2 sides that constructed as congruent, and then the 2 are the 1 angle. This is what creates the side angle side, right? or SAS congruence between the two of these, right? So as long as I have two sides, just two sides, and one angle, my triangles are congruent. But gentlemen, my angle has to be in between the two sides. It has to be sandwiched in between. That's what it means to be included, okay? So here we go. Blow this up a little bit. SAS applies if I have two sides and the included angle of one triangle congruent to two sides and the included angle of another. Okay, so let's do a couple proofs using this, right? So I'm going to walk you through two proofs rather quickly, actually. So here we go. Creating my congruent creating my triangle. I'm going to drop down a line here with a right angle. I'm going to call this guy A, B, C, D. And what we're given here is the following. We're given that B is the midpoint of AD. And moreover, that angles ABC and CBD are right angles. And we're going to prove these two triangles, ABC and DBC, to be congruent. Okay, the two triangles inside of the larger triangle. So of course, we're going to do our two-column proof. We have our statements column, we have our reasons column, right? And again, we don't need 6 total things. We're only going to need 3, 2 sides and 1 angle to prove our congruence. So B is the midpoint of AD, excuse me, and triangle ABC and CBD are right angles. Okay, so let's find some congruent sides. Well, we should know that AB and BD are congruent. They're going to have to be, right? So this is the first congruent statement we need, one of 3 that we're going to need total, right? And the reason that these guys are congruent is because they just told us that B is the midpoint. So that's the definition of the midpoint, right? Remember, all of our reasons to give sufficiency here have to be either definitions, properties, postulates, or theorems, okay? So we have to be succinct here. Moreover, let's take this side right here, BC. Well, of course, it's equal to itself, BC, and the property that states that is the reflexive property, which I know we kind of made fun of before. But there we have our necessity, right? Why we have it. We have now 1, 2 things congruent, and we're going to need a total of 3, right? So we have our 2 sides. Now it has to be the included angle. It has to be the one sandwiched in between. So it is sufficient to say that ABC and CBD, these guys are congruent. They're both defined as right angles, and all right angles are congruent. It's actually reasoning we just recently used. Okay, so now we have all 3 things. Okay, we have 2 sides and 1 angle, the angle included. Therefore, we can say that triangle ABC is congruent to triangle DBC, and that's from the side angle side postulate. Side angle side, triangle congruence. Okay, last but not least, here we go. Last diagram. Remember in our previous lesson that we have geometry textbooks very popularly like to use parallel lines, which are going to have you deduce that the alternate interior angles are congruent. In this case, this is the other popular one where we have 2 intersecting lines, okay? And typically what we're looking for is for verticals to be congruent. So we're already given 2 sets of congruent segments. We have RT congruent to TP, and then we have ST congruent to TQ. And what we're going to prove here is we're going to prove 2 triangles. So those triangles are going to be triangle PTS and RTQ being congruent, okay? So let me just sketch those out. That means that PTS, this guy, and RTQ, it's those two, okay? So let's go ahead and do our proof, right? 2 columns. This is gonna be a quick one, I think, right? Because it looks like we already have 2 of our sides given in step 1, right? RT congruent to TP, ST congruent to TQ, and that's given. Okay, well, if we can prove those angles, right, and we can, right? We know that angle STQ has to be congruent to angle RTQ, right? And that's because those angles are vertical. And that's the relationship there. So boom, we already have, right? I'm going to mark this guy, and this guy are congruent. Therefore, we have our included angle, and we can then state that triangle PTS is congruent. It's all the information we need, just 2 sides and 1 angle as long as the angle is included. So triangle PTS congruent to RTQ, and that's the side angle side. Your answer, when you prove 2 triangles to be congruent, has to be a 3-letter answer. On this assignment, it will only be side angle side. I caution you against not having that angle included. That may be kind of a potty mouth postulate if we were to spell that, right? If the angle were to come outside of the 2 sides, ASS, that's not good. So go ahead and complete your assignment. Email me if you have any questions.